Okay guys, today I want to talk about factors that affect climate. And we've talked about this quite extensively in class, so this is just going to be a really quick overview of factors that affect climate. Alright, so if you'll remember, we used this handy acronym in class to help us remember the factors that affect climate. So we're just going to go through this real quickly here. On this particular slide, I'm only going to talk about the first one, which is latitude. But let's go ahead and list all of them, excuse me. The A, I believe, stands for air masses. The M is for mountain barriers. The E is for elevation. The C is for continental location. Continental location. Okay, when I say continental location, we'll talk about this in a second. I mean, where are you on the continent? So if you're right here where I'm making this dot, you're in the middle of a continent. If you're right here, you're near the ocean. So we'll talk about that and how that affects everything. The O is for ocean currents. And I believe the W is for wind, or maybe wind system. Alright, in my class we really didn't talk about wind system, and we really didn't talk about air masses or air pressure. Although those are important, we really focused on latitude, mountain barriers, elevation, continental location, and ocean currents. So I'm going to go ahead and erase that. Hopefully you've got that if you're taking notes. Alright, so latitude, let's go over that one really quick. As you know, this line I'm drawing here is the equator. This is 0 degrees latitude. Okay, and basically between the tropics, which is the Tropic of Cancer right here, and the Tropic of Capricorn right here. Okay, the weather right in this area is going to be tropical. Okay, tropical. So pretty much you can bet that if you're in this zone, it's going to be pretty warm, and it's going to be pretty warm all year long. All right, and that's based on your latitude, of course. All right, now if we go up here above, let's say 60, I don't know if that's 60, I can't see my line, and below 60, okay, this is what we call the polar zones. Polar, again based on latitude. So if you're in the polar zone, you can bet that your climate, your temperature is going to be very, very cold. All right, and then in the middle, we have something called temperate. Okay, another word for temperate is moderate. All right, and this is where you have seasons. Seasons. All right, so in June, up here in the north, it's the summer. In June, in the south, it's the winter. All right, so that has to do with the tilt of the Earth, of course. And so that's latitude based. Okay, mountain barriers. We talked about mountain barriers, and we talked about the Pacific Northwest in the United States. That's where we see this occurring a lot. Although it's not the only place, this is the place we're probably most familiar with. So basically what happens here, let me just color this in. This is the ocean, right? This is the ocean. All right, and if you have wind coming off the ocean, okay, wind is going to carry moisture. And as the moisture goes over the mountain, it's going to be forced up this mountain. What's going to happen to the temperature? Okay, the temperature is going to drop. The temp drops. Okay, and as the temperature drops and the pressure decreases, you're going to have rainfall. And we call that rainfall orographic precipitation. Precipitation. Man, my handwriting is horrible. Alright, as the moisture goes over the mountain, the mountaintop, it's going to be forced back down. And as it's forced back down, the temperature is going to increase along with the pressure. Okay, when that happens, all the water is going to evaporate off, and you're going to have very little rainfall over here in this area. Okay, very little rainfall. And that's called the rain shadow effect. Okay, so on one side of a mountain, on the windward side, you're going to have very wet conditions. It's very likely you could have a forest or a lot of vegetation over here. Whereas on the other side, you're going to have what's called the rain shadow, and it's going to be very dry. So that's the M for mountain barriers. The E for elevation. You guys know pretty much about elevation, so I'm going to do it really quick. I'm going to draw a line of latitude, and I'm going to draw 2 dots on there. We got city A and city B, and city B is near sea level. It's, let's say it's 50 foot above sea level, and city A has a lot of mountains. It's 5,000 feet above sea level. So even though these cities have the same latitude, city A is going to be much colder than city B. That is the E for elevation. Okay, continental location. So continental location is probably the hardest one to understand, but the most important point you need to remember for continental location is the idea that water heats and cools more slowly than land. Okay, so what that means is if you were on the coast, let's say San Francisco or just anywhere on the coast, you're going to have a more stable temperature, And that's because the ocean doesn't heat up or cool off very quickly. Okay, and the wind that's blowing off the ocean, it just picks up that temperature, and it helps to stabilize those cities that are on the coast. Okay, if you're in the interior of the continent, okay, land can heat up and cool off very quickly. So land can be varied. So if you're in the center of the continent, you'll have a varied climate. Alright, and if you're in the ocean, or if you're near the ocean, excuse me, you will have a stable climate. So ocean, stable climate. Okay, and this idea that oceans heat up and cool off very quickly, it also affects wind patterns, which if you've seen the other video on monsoons, that explains how monsoons happen. Okay, so that is the C continental location effective climate. Ocean currents. Ocean currents, it says here, are giant rivers of seawater flowing at surface of oceans. Not all ocean currents are at the surface of oceans, so I probably need to correct that. But ocean currents can be either warm or cold, okay? And they basically act as the heating and cooling system of the planet, okay? So they circulate warm and cold water all over the planet. And that's very important. If you're near a cold ocean current, chances are you're going to get a cool ocean breeze, and that's going to affect your climate in the way that it cools your city or wherever it is you're living. And it says here, ocean currents flow in circular paths. Alright, so let's go to a map of ocean currents here real quick. Let me skip the YouTube video. Erase this. Alright, so here's a little diagram of how ocean currents flow. And see, they're mostly in circular paths. Okay, so ocean currents affect temperature, because if you're near a warm ocean current, like say Miami here, it's going to heat up your city a little bit, right? And plus, if you're on the coast, it's going to have a stabilizing effect on your climate. So that is the O for ocean currents.